So now let's talk about faults instead of the joints that we just talked about. So faults are where we actually get displacement, where our rocks are breaking and they're physically moving. So if we take a look at this picture here, you can see there's a fault line right there, right, where you can see this river's offset here. Well, this is a fault, right? These rivers once matched up, but there was earth movement, right? And they have physically moved directions. So we can classify our faults into three different general groups. The first are called dip-slip faults. And a dip-slip fault is where we have up and down motion. A strike-slip fault is where we have side-to-side motion. And an oblique slip fault is really what we get in nature, where we have both up and down and side-to-side motion. So an oblique slip, as you can see down here, you get some of both, right? You see upward movement and sideward and side movement. So if we just take a look at each type, so there's three different types of dip-slip faults, right, in the way that our blocks move. Now, in order to tell which side is which, we first have to get a little bit of terminology down. So I want to draw you a little picture up here. So let's say we have a fault, right? There's our fault line. And we can see that our rocks have been displaced, right, because my layers here don't match up anymore. So we need to give a term to the left side of the fault and the right side of the fault in order to talk about what's going on. So the way that we do this is you got to pretend that you could go down inside the earth and stand on the fault. Whichever side your feet would be touching, which would be this side, that would be called your foot wall. The other side would be the one that's physically above you, right? You could hang a lantern on it, and that's what we call our hanging wall. So we're going to talk about motion in relationship from foot wall to hanging wall. So let's take a look here. Let's draw this the other way. So let's say there's my fault. You see how if I stood on here, my feet would be on this side. So that's my foot wall, and the other side's my hanging wall. So we're going to talk about the relationships of sides moving to each other based on the foot wall versus the hanging wall. So again, if we look here on all this diagram, since our faults are all facing the same way, the foot wall is down there and the hanging wall is up here. So let's take a look at each type. So the first type is a normal fault. And a normal fault is where my hanging wall moves down relative to the foot wall. So here's the fault line, right? You can see that my layers are displaced. So again, right, if I could stand on here, right, this would be my foot wall. Here's my hanging wall. And you can see that my hanging wall has moved downwards in relationship to the foot wall. Now, the important part here is to realize at what setting does this occur. That we normally get our normal faults at divergent boundaries. This is a result of pulling apart. Right? When you pull two blocks away from each other, right, they're going to slip downwards in relation. Then we can take a look at our reverse fault. So a reverse fault is where our foot wall moves upwards relative to the foot wall. So here, right, they've labeled this out here for you, but here's your fault line. And this layer here should match up with this layer here. See, here's my foot wall, here's my hanging wall. So my hanging wall has moved upwards, right, in relation to the foot wall. The important thing to realize is this happens due to compression, so this happens at convergent boundaries. Right, when I'm pushing two blocks together, this one's going to have to pop up in order to relieve the stress. That's a reverse fault. Now, a thrust fault has the same kind of motion, but what makes it different is the actual angle. So on a reverse fault, well, let's see, on a thrust fault, the actual angle of the fault line has to be less than 35 degrees. And the reason why is really simple. There's more movement on a shallow fault than on a steep fault. Think of it this way. If you were to move, right, you're going to pack a U-Haul full of your stuff. You want to get a U-Haul that has a nice long incline on it so that way you can walk all those heavy boxes, right, up that nice shallow slope. If you got a U-Haul that didn't have one and you had to lift the boxes straight up in there, well, it takes more energy. So what we see is with our thrust faults, because it's a low angle, that these rocks tend to get ramped up to the surface a lot easier than in a reverse fault. And that's why we categorize between the two. But I do want you to realize that the motion is actually the same. Then we have our strike-slip faults. And our strike-slip faults, like I said, is just side to side motion. So you're really only going to have two options here if you're talking about side to side motion. Either you're going to move to the right or you're going to move to the left. And the way that we figure this out is really pretty simple. So let's take a look at this left lateral here. So let's say that there's a road that goes here, all right? Obviously the road is displaced. So if I was walking on this side, right, and I was walking down the road and I got to the fault, I would have to move to my left to get back on the road. That's what makes it a left lateral. Now here's the other beautiful thing. If I was maybe walking, say, on this side of the road, if I got to the fault, you see how I would still have to move to the left? So either way you look at it, you have to move to the left, right? And it would be the same thing with your right lateral. So these lateral faults are actually pretty simple to tell the difference because you're looking for those visual cues to figure out which way the block actually moved. And we tend to find our strike slip faults at transform boundaries, which should make sense because transform is a side-to-side motion. Now, sometimes it's really hard to tell a fault. Right? When you look at this rock layer, this fault may not be obvious that's in here at first because everything is nice and layered. However, you might start to notice, right, that there's a line, okay, that comes across down here. There's your fault line. The easiest way to look for faults is see these dotted yellow lines. They're tracing out the same rock units and where they're displaced. In places like this where all the rocks look the same, it's a little bit difficult. In areas where you have highly colored rock, like we saw with the normal fault, it makes it a lot easier to tell where those faults actually are. Now, we usually find, when we find faults, we don't usually just find one fault, right, like one strike slip or one normal fault. We usually find a whole bunch of them together, and that's what we call a fault system. So here, for example, we've got a compression boundary at a mountain, let's say, right? We're compressing this area. If you compress something, it's not just going to break in one place. You see that it's broken in several places, and it's all getting crunched up. So you see here I have a whole bunch of reverse faults, right, where my hanging wall has moved up relative to the footwall. So we're going to, in our mountain systems, we're going to find a whole bunch of them together. And we can see the same thing with our normal faults, right? As we're stretching an area out, right, it's not just going to break in one spot, it's going to break in a whole bunch of spots, right, as my rock is getting stretched out. So usually when we find our faults, we don't just find one of them, we find a whole system of them.